The exploration of the vast expanses of space has fascinated humankind for centuries. This fascination culminated in the mid-20th century with the first successful launch of an artificial satellite, Sputnik 1, by the Soviet Union in 1957. The following decades saw a race between global superpowers, resulting in landmark achievements such as manned missions, lunar landings, and exploration of other planets in our solar system. Recently, China has emerged as a formidable player in space exploration, signaling a new phase in this exciting field. China's foray into space exploration began with the launch of its first satellite, Dongfang Hong-I, in 1970. However, its major strides have been made in the last few decades, marking its position in the new space race. One such remarkable stride is China's Lunar Exploration Program, a systematic, phased mission to explore the Moon's topography, geology, and mineral resources. The significance of this topic lies in the understanding it provides about our nearest celestial neighbor and the immense potential it holds for the future of space exploration. By delving into the intricacies of China's lunar exploration program, we gain valuable insights into the capabilities and vision of one of the leading players in modern space exploration. Moreover, by understanding the implications of China's discovery of an estimated 270 billion tons of water on the Moon, we can look forward to the revolutionary changes it might bring to the future of lunar colonies and further exploration of space. Welcome to Innovative Czech YouTube channel. Don't forget to subscribe and leave comment below this video. The fascinating history of space exploration witnessed its significant turning point during the Cold War era. The former USSR and the US locked horns to dominate the space frontier, resulting in a slew of significant milestones, including the successful launch of the first artificial satellite, Sputnik, the first manned mission, Yuri Gagarin's spaceflight, and the landmark achievement of the US Apollo 11 mission's moon landing. The European Space Agency, ESA, despite being a later entrant, made its mark with an array of exploratory missions to various celestial bodies. Each accomplishment, each discovery brought a greater understanding of the cosmos and fostered the thirst for further exploration. The entry of China in this competitive field was relatively late but equally significant. China's early space endeavors were characterized by trials and errors, much like the initial efforts of their Western counterparts. The launch of the first satellite, Dongfang Hong-I, in 1970, opened the doors for China's space exploration. This historic milestone was followed by an array of exploratory missions and technological advancements, ultimately leading to the Chang'e lunar program's conceptualization. China's Lunar Exploration Program, named after the Chinese moon goddess, Chang'e, is a multi-stage mission aimed at exploring the Moon systematically. The Chang'e program's sequential missions were designed to gradually elevate China's lunar capabilities, starting from orbital reconnaissance to soft landing, and ultimately, sample return. The program encompasses several stages. Chang'e 1 and 2 were responsible for lunar orbiting and mapping, Chang'e 3 and 4 for landing and roving, and Chang'e 5 and 6 for lunar sample return. Each Chang'e mission has not only advanced China's lunar exploration capabilities but has also achieved remarkable scientific outcomes. The most significant of these is the discovery of vast amounts of water on the Moon, estimated at approximately 270 billion tons. This breakthrough has profound implications for the future of space exploration. The discovery of water in space is more than a mere scientific novelty. In the context of space exploration, it is a game-changing resource with potential to sustain life and fuel spacecraft. With the presence of water on the Moon, future lunar colonists could use this resource to support life, for drinking, growing food, and perhaps even extracting oxygen for breathing. Additionally, water can be split into hydrogen and oxygen, two gases that could potentially be used as rocket fuel. This implies that the Moon could serve as a refueling station for spacecraft, significantly reducing the cost and complexity of missions aimed at exploring deeper into the solar system. The reason China's burgeoning space program plans to place astronauts on the Moon before 2030 is because the wish to understand the Moon and colonize it. The Chinese lunar water discovery has inevitably shaken the global space community. While NASA and other space agencies are formulating their response to this paradigm shift, there is an unmissable change in international space relations. The competition that was once dominated by the US and the USSR has now opened up, bringing more countries into the space race, each aspiring to harness the resources and potentials that space offers. Looking ahead, it's important to consider the broader implications of these developments. China's accomplishments could inspire other countries to invest in their space programs, leading to a surge in space exploration activities. On a grander scale, this could propel humanity closer to the dream of establishing human colonies on other celestial bodies. As we push the boundaries of our capabilities, who knows what possibilities might unfold? China's lunar exploration program, through its achievements and discoveries, has brought us one step closer to answering some of the most profound questions about our place in the cosmos. As we look at the potential impact of China's lunar water discovery and its broader implications, it's also worth exploring the ethical and legal considerations related to space exploration. Who has the right to the moon's resources? What are the ramifications for international relations and space law? However, the discovery of vast amounts of water on the moon has raised new questions about the exploitation of lunar resources. If water is a key resource for space exploration, who gets the right to extract and use it? The answer to this question is not straightforward and is subject to ongoing international debate. The U.S., through the Artemis Accords, has proposed a possible solution. The Artemis Accords, signed by several countries, including the U.S., the U.K., and Canada, establish safety zones around future moon bases to prevent damage or interference from rival countries or companies. They also allow for the commercial extraction of lunar resources, with the caveat that such activities must be conducted for the benefit of all humanity. However, China and Russia, major space powers, have not signed the Artemis Accords. Both countries argue that the exploitation of lunar resources should be regulated under a United Nations framework rather than a treaty led by one country. The differences in views among the leading space powers suggest that the legal and ethical issues surrounding lunar resource extraction remain unresolved and may potentially cause conflicts in the future. As we continue to push the boundaries of space exploration, the need for a clear, internationally agreed framework for lunar resource exploitation becomes more urgent. The challenge lies in balancing the drive for exploration and technological advancement with the need for equitable distribution of space benefits and the preservation of celestial bodies for future generations. On a broader scale, the discovery of lunar water has further catalyzed the human desire to explore and understand our universe. It has reignited the dream of establishing human colonies on other celestial bodies, and has brought us one step closer to answering the fundamental question: are we alone in the universe? The exploration of outer space has always been a matter of fascination and curiosity for mankind. The Moon, being the closest celestial body to our planet, has been the subject of numerous explorations, landing missions, and probes. However, it was a recent discovery by China that truly shocked the world and brought about a paradigm shift in the realm of lunar explorations. China's space program revealed the presence of 270 billion tons of water on the Moon. This monumental discovery not only changes our understanding of the Moon but also opens up possibilities for future lunar colonization. This video discusses China's significant discovery on the Moon, the implications for the global space race, specifically between China and the United States, and the potential for lunar colonization. Discovery that shocked NASA: China's discovery of water on the Moon. China's space program has been a global contender in the realm of space exploration and technology. The country's endeavors have seen a significant increase over the last decade, with billions of dollars being funneled into groundbreaking projects and initiatives. China's progress in this realm became especially evident with the successful launch of their own International Space Station. However, it was China's moon mission that truly caught the world's attention. The robotic spacecraft, Chang'e 5, successfully made a precise landing near Mount Rumker on the Moon's Oceanus Procellarum, also known as the Ocean of Storms. It collected lunar samples and brought them back to Earth. After meticulous analysis, it was revealed that these samples contained water. This discovery was truly astounding. Previous theories had suggested that the Moon was essentially dry, with the massive heat caused by the Moon's creation believed to have evaporated any water. Yet, recent exploratory missions and observations have confirmed the presence of water, primarily in the form of ice. This water is predominantly located near the lunar poles, in shadowed regions that have remained unexplored by other nations, including the U.S. The study of the lunar samples brought back by China's Chang'e 5 revealed the presence of impact glass beads. These tiny grains of differently colored glass, formed at high temperatures during meteorite impacts on the lunar surface, contain water. This water exists in its molecular state, or more likely hydroxyl, consisting of one hydrogen and one oxygen atom. Estimations indicate that the Moon may harbor 270 billion tons of water in the form of these impact glass beads, a significantly larger reservoir than previously anticipated. The implications for China's space program and lunar colonization. The discovery of such vast reserves of water on the Moon has significant implications for China's space program and the future of lunar colonization. For one, water is a crucial component for life as we know it. As such, the presence of water on the Moon is a prerequisite for establishing habitable environments there. Water is a critical resource for any prolonged human presence in space, primarily due to its role in human sustenance and potential use in producing rocket fuel. In the context of a potential lunar colony, the discovery of water increases the feasibility of long-term human survival and the establishment of a self-sustaining lunar base. The presence of this amount of water on the Moon could transform lunar missions from one-way trips to an orbital cycle, where spacecraft shuttle between the Earth and the Moon. Water can be broken down into hydrogen and oxygen, key components of rocket fuel. This capability could transform the Moon into a fuel depot for further space exploration. Moreover, the availability of water also means the potential for producing rocket fuel. Scientists can now theoretically use the water on the Moon to produce hydrogen, which can be used as a carbon-free energy source. This discovery, therefore, empowers further exploration programs. Furthermore, with a lunar base, the Moon could potentially serve as a launching site for future missions to Mars, thereby shortening the time needed to reach the Red Planet. Additionally, water is essential for agriculture. If astronauts are to be self-sufficient on a lunar base, crops would need to be grown on the Moon. This means that China's discovery could facilitate the development of space-based agricultural endeavors. China's space program has gained significant momentum over the past few decades. Unlike the early days of the space race, the nation's journey into space has been a systematic, phased approach. The China National Space Administration, CNSA, initiated its lunar program, named Chang'e after the Chinese moon goddess, in the early 2000s. The primary objective was to explore the Moon's topography, geology, and mineral resources, with an ultimate goal of human lunar missions and establishing a robotic research base. The most recent mission, Chang'e 5, returned lunar samples to Earth for the first time since the Soviet Union's Luna 24 mission in 1976. The probe collected the samples from the Oceanus Procellarum, a vast lunar mare on the western edge of the near side of the Moon. The discovery of an immense volume of water hidden within these lunar samples has drawn significant attention and challenged prior assumptions about the Moon's aridity. The space race between China and the United States. China's discovery of water on the Moon has significantly escalated the global space race, particularly between China and the United States. For decades, the U.S., through NASA, has been a dominant player in space exploration. However, this recent discovery by China poses a significant challenge to America's leadership in this realm. The U.S. had plans to target the Moon's poles, the same areas where China found water, within the next 50 years. Now that China has made this groundbreaking discovery, it has gained a significant advantage in the space race. China has plans to send its astronauts to the Moon by 2030, and this discovery might expedite those plans. NASA's Artemis program aims to return humans to the Moon by 2024, focusing on the lunar South Pole due to its speculated water ice deposits. China's discovery might spur NASA to accelerate its program, leading to increased cooperation or competition between the two nations. In response to China's advancement, NASA has accelerated their Moon program. The U.S. is now keen on advancing its lunar program, Artemis, which aims to return humans to the Moon by 2024. The competition between these two major powers is expected to drive further innovation and breakthroughs in space exploration and technology. The discovery of 270 billion tons of water on the Moon by China is truly a game-changer in the field of space exploration and technology. This discovery not only changes our understanding of the Moon but also opens up a whole new world of possibilities for future lunar colonization and deep space explorations. Moreover, this discovery has significantly escalated the global space race, especially between China and the United States, propelling both nations to fast-track their respective lunar programs. With both nations vying for supremacy in space, the coming decades promise exciting advancements and innovations in this realm. The discovery has also sparked discussions and debates regarding lunar colonization. With the presence of water, it becomes feasible to establish lunar bases that can support life and agriculture, serving as stepping stones for future explorations to Mars and beyond. While the implications and potential of this discovery are immense, it also raises several questions and concerns regarding space governance and ethical considerations related to lunar colonization. Nevertheless, the discovery of water on the Moon is a significant milestone, a giant leap forward in the quest to unravel the mysteries of our universe. Who will be the first to colonize the Moon, and who will be the first country to colonize Mars? Guys, leave your comment below on whom you think will get there first and who will have a real footprint on the Moon and Mars. Don't forget to like our video, follow and comment. God bless you.